Today we will be learning a machine learning topic, that is train test split. Okay, the topic is train test split. So at first, if you train a model, suppose the model is suppose a model that is decision tree. Okay, the model is decision tree, and the model accuracy is 1, or you can tell the model accuracy is 0.98. This is excellent accuracy, but this model fails in some cases. Like in some cases the model giving the wrong prediction or unpredictable answers. Okay, so the model is giving, like, the model accuracy is excellent, but the model is not reliable. So every time if you get the model is giving excellent accuracy, that not mean that the model is actually excellent or the model is doing great work. Because suppose you have the data, you have some data, this is x, this is y, this is input, this is y is output. Okay, and you have a model decision tree. You have trained the decision tree model using this data. Okay, and after training you are testing the model. Obviously you have to test the model because the model is trained, but you have to test the model accuracy, or you have to test the model performance. So for that you have to test the model, and you don't have extra data to test. So you have took some data from this training data set, and you have test the data using this decision tree model that you have trained. Okay, and you have suppose got 0.1 accuracy, sorry, got 1.0 accuracy. This means the model, your decision tree model is giving 100% correct answer. Do you know why this is giving 100% correct answer? Because suppose suppose there is, we can take an example, a very easy example. Suppose here is a suggestion paper suggestion for the semester, suggestion for semester. You have read this suggestion and you have read all the questions and answers from this suggestion, and next then in the exam you have got the same questions. Okay, so this is predictable, like you will get the 100% number. In real life this is not possible in many cases, but in theoretically you have read the all question and the same question are given in the exam also. So you are taking part in 100% question, you have attempted 100% question, and you are getting 100% marks because you know the all questions and all the answers. Okay, this is a scenario. And the same scenario is happening here also. Here the decision tree model know these data, the decision tree model is trained using this data, and you are also testing the decision tree model using the same data. So the decision tree model is already aware of the data that you are testing. Okay, so this is giving 100% accuracy. This is the problem, but you cannot test the model, like, or you cannot tell that the model is 100% accurate, because the model data which you are testing that is already known from previous. Okay, so what we can do, like what we can do, train test split. What is train test split? Suppose you have a data set x and y, and you suppose you have separated some data from the beginning, from the whole data set you have separated some data for testing. This you will use for testing, for only testing. This will not go to the training phase. Okay, this is for only testing. So you have trained the SVM model, using this data, using this data, this portion of data. Okay, you have trained the model, and after training you are testing using this data. Okay, now you will get the correct answer or correct accuracy, because this data is not known from before. Okay, so you can get the correct accuracy. Obviously this accuracy will be low from before. Here you can get 1.0 accuracy, but here you can get 0.99 or 0.98 or whatever, 0.9 suppose. Okay, but this is the correct accuracy, because here your SVM model is not aware about this data. He is taking knowledge from the trained data, and you are testing using a new data that is not known to the SVM model beforehand. Okay, so suppose now how the train test split function is working. Suppose you have a data like x is equal to the training data. Suppose this is a 1D data, 1 2 3 4 5 6 8 9 7 8 8 9 10. Okay, this is x and this is y. Suppose this is classification, so 0 1 1 1 0 0 0 1 0 1. Suppose this is the y column. Okay, and you are doing train test split. Suppose this is x, this is y, 1 2 3 4 5 6 7 8 9 10, 0 1 1 1 0 0 0 1 0 1. This is the whole data set, and you are taking the train test split. Here you have to understand, like here is total 4 parameters by default, x, y, and random state. You can use random state. Random state is equal to 42. I will tell you later that why 42 is given, and the test size is equal to whatever you can give, 0.2 or 0.25 or 0.3. Suppose this is 0.2. So this is x, this is y. You are giving the x and y. What is test size? Test size is 0.2, means what your data is. Your total data is 10. Number of data is equal to 10. From that you have to take the ratio 0.2 as the test size. Okay, so for 10.2 means 20%. Okay, means you are taking 20% of the whole data as test data. You are taking this. So 10 20 by 100, this will be 8. Sorry, this will be 2. So you are taking only 2 rows out of 10 rows as your test data. So okay, okay, suppose so from here 1 2 3 4 5 6 7 8 9 10, from here you are taking only 2 rows. Take only 2 rows as test, 8 rows as train. Okay, so how this is, like you have taken 1 2 3 4 5 6 7 8 9 10 0 1 1 1 0 0 6 0 1 0 1 0 1 1 1 0 0 1 0 1. Suppose you have taken 6 and 9 as the test data. So these are the test, and others whatever there is, the data are the trained data. Okay, so yes, so this is the test, this is the train 7 and 6 and 9. Suppose for simplicity I am taking the test data is like 9 and 10. I am taking 9 and 10 as the test data and other as the train data for simplicity. Okay, so if you calculate the wait, at first, what is random state? The random state is 42, or you can give any number. Okay, and if you define the random state, this will give the same split in every run of the code. Suppose in first run you are getting 9 and 10 as the test data and 1 to 8 as the train data. In the second run you have run the code second time and you are getting 3 and 4 as the test data and others as the train data. This is not like a good practice, so we have defined random state is equal to 42. This will create a constant test and train, means every time you will run the code, this will generate a fixed train and test data. Okay, and test size, I have already told you, test size 0.2 means 20% of the whole data as the test data you are taking. So this all done. And one thing, suppose you have this data. Suppose you have this data x1, x2, x3 and y. This is total x and this is y. And here the number of rows are 100, suppose. Okay, so here how the x train or the train test split is how used. Suppose this is the total data frame, and from this I have got x and y. X contains all x1, x2, x3 and y contains y. Okay, so suppose x train, x test, y train, y test is equal to train test split here you are giving these x and y, x, y, random state 42 and the test size is equal to 0.2 suppose. Okay, so what the x train, suppose this is the yes, suppose this is the test data. Okay, this is the test data and the rest of the data training data. These are the training data, these are the train and these are the test. Okay, so from here you can see that this portion this is called x train. The training data is divided into two parts, test data is divided into two parts. The training data is divided into two parts, that is x train and y train, and test data is divided into two parts, that is x test and y test. What is x train? This is x train and this is y train, this is y test and this is x test, because this is the whole test data, and from there this portion particularly this portion is of x part. So the whole data is the test data and this part is the x. So this part we can tell that this is x test. Okay, and this part is y data, so this is y test, and this part similarly this part is y train and this part is x train. Okay, so you have got the idea what is x train, y train. So suppose this is 100 and the number of all the columns are 4. So the data frame size, the data frame shape, suppose say shape of data frame, this is 100, 4 because total number of rows, total number of features. Okay, so you tell me that if this data is 20% and this data is 80%, because we have taken the test split is 0.2, test size is 0.2, so this is the distribution. So if you get this, then x train, the shape of the x train will be what, shape of the y train will be what, shape of the x test will be what, and shape of the y test will be what. Shape of the x train will be, suppose this is the total data, this is y, this is x, this is y, and these are 20 and these are 80, because the total data is 100, 80% of 100 is 80, so this portion is 80, this portion is 80, so the x train, this portion of the x train will be 80, the train shape will be 80 comma 1 2 3. Okay, y train shape will be 80 comma 1. I can write, but in the convention there is not written 1, so this will be only 80 comma. Okay, 80 is the number of row. In the y also there is, you can see that the number of rows are 80 and number of columns are 1. In the x test, this is the x test, this is the x test, you can see this is the x test. The number of rows are 20, so 20 you can write, and the number of columns 1 2 3. And for the y test also there is 20 comma. These are the total shapes of the x train, y train, x test and y test. Okay, so let's try with code. Okay, suppose I am taking a example like I am importing the train test bit, scikit-learn dot model selection train test bit, and suppose I am taking x is equal to 1 2 3, rather than I am giving a loop I for I in range 1 to 10 11. That is that will give me the array like 1 1 2 3 dot 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 10. Okay, and the y is like 1 0 1 1 1 0 1 0 1 okay, this is y. So apply train test bit x train. At first check the okay, x train, x test, y train, y test, train test bit. Here I am giving x and y. Random state is equal to 42 and test size is equal to 2.2, that is 20%. So I am printing all these x train, x test, y train, y test. You can see that in the training here is 8 numbers and in the test here is only 2 numbers. Okay, so this is the x train, this is the training, these are the training. Okay, and 92 and 00, these are the test data. So let's suppose I am adding a data set, add input data sets. Suppose this is the data set I am adding, smartphones plain. Okay, so the data set is added. Df is equal to pd dot read csv and the dataset path, and you can see the data frame. This is the dataset. The dataset is very large, and the dataset contains 1006 rows, 1006 rows and 29 columns. Okay, So at first specify the x and y. Specify the x and y. How to specify? X is the input columns. Okay, x is equal to df dot drop. Okay, sorry. Yes, df dot drop columns x means all the columns that will exclude the target column. Suppose here I am taking the target column as price numeric. Okay, this is the target column, suppose I am taking. So this is the x and y is equal to df of that target column. Okay, df of price numeric. I think this is print x, print y. This is x and this is y, you can see. So x and y are specified. Suppose here x train x test and y train y test. Train test split x comma y. Yes, here you can check the shape of print x dot shape, because this is the data frame. Print y dot shape. What will be the shape? The shape will be this. Here again. Okay, the problem is here. The shape is not a function, the shape is an attribute. So yes, the x shape is 1006, 28. 28 why? Because here is 29 columns, one is the target column, so one column is removed, that is the price numeric column, and you have in x 28 columns, so 28 columns and 1006 rows, that is total 1006 28, and for the y, that is only 1006, and here is one column only. Okay, so y random state is equal to 42, test size is equal to 0.2. So here print x train comma x train x train y train x test y test, and after that I want to print all the shapes of the four data frames. Extend dot shape, okay. What this will print? This will print extend dot shape. For x train, this is the for x, this is the whole number of rows 1006. From there we are taking train as 80%, because the test size is 20%. So 1006, the 80% of 1006 means 1006 into 0.8, 804.8. Suppose this will, I think this will, I can got 804 comma 28. Okay, And for y train 804, this can be 805 also. After the run I can tell you 804 comma, and for the x test, that is 0.2, it is 201. Okay, 201 comma 28, because this is of the x portion. 201 comma, suppose run the code, and what you can get 804 comma 28, 804 comma 202 comma 28, 202 comma. Okay, this you can get. This is the train test split. And now you can try, like, you will be training your model using this x train and y train in the fit function, dot fit function. You will be giving x train and y train rather than giving the x and y. Okay, and in the time of testing you will be using x test and y test. For prediction you will use the y test, and for prediction you will use the x test, and for the evaluation or for the accuracy you will use the y test and the y pred that you will be getting from x test. Okay, so that's all. Okay, goodbye.